In this unit, we're going to kind of continue transformations a little bit, except we're going to talk about a specific type of function. Okay, so like I said, we're going to be looking at a lot of different functions this year. And one of the things that we're going to look at with each of these functions is how to graph them. And another thing that we're going to look at is when we're given graphs, how to find equations of them. And then we can also see how we can use some of these functions. So we're going to talk about radical functions. When I say the word radical, can somebody answer this? What do you think? Square root, yeah, okay. That's the most common type. There can be cube roots, there can be fourth roots, but good. Okay, and we are going to be dealing with just the square root radicals in this one. So we're going to talk about what its graph looks like. Okay, we don't really talk too much about how it's used, but I mean, it can be used, it has financial uses. You can talk about investment growth using radical functions. You can actually use it in forensics with radical functions. You use radical functions to determine, like at an accident, if you know how long a, oh my God, now I can't think of it, skid mark. If you know how long a skid mark is, you can use a radical function to figure out how fast the vehicle was going. Okay, so I mean, there are some uses of this. So basically, a radical function involves a radical with a variable in the radicand. Remember, the radicand, that's just whatever's under the square root. And just like we had the transformation equation that we used in the first unit, we can use a transformation equation in the second, or in this one. But we don't use f, we don't use the fancy f. Instead, we use the radicals. So we can talk about transformations that look like a square root b parentheses x minus h, and then at the end, plus k. If you know the most basic radical one, you can figure out all the transformed ones using this equation that we've already seen in the first unit. What does A represent again? Vertical stretch if it's negative. B, stretch, and if it's negative, flip. H, horizontal shift. K, vertical shift. Okay, good. Now last year, when we did parabolas or quadratic functions, we started with the most basic one. That was the one that started at 0, 0, and then we went 1 across, 1 up, 2 across, 4 up. And then we did shifts and stretches from there. So we want to find what's the most basic radical function. And the best way to find what a basic radical function looks like is do a table of values and see what appears. Okay? So I'm going to pick values here, and then to find the value of y, I have to take the square root of the values I choose for x. What would be a good number to choose for x so that when I take its square root, I get a whole number? 4. Any other ones? We don't want to get too big, but 9 is right. Can you go lower than 4? 1. Square root of 2 is not going to be a whole number. Can you go lower than 1? 0. Right. Can you go lower than 0? Why? Why can't you? You can't take the square root of a negative. So if x is 0, what's y? 0. If x is 1, what's y? 1. If x is 4, Like you guys said, what's y? That'll be enough for us. So if we plot those values, 0, 0, 1, 1, and 4, 2, and yeah, we could have gone 9, 3. But you can see the shape it's going to take. It's going to be a curve. And actually, it's like a halfway sideways parabola. This is the most basic one. Those are the reference points you want to remember for the most basic one. 0, 0, 1, 1, 4, 2. Okay? And we're going to see that with different functions we do throughout the year. There's going to be basic ones, like when we do exponential ones, and then there's going to be basic points. What's the domain of this? 0 to infinity. What's the range? 0 to infinity. Good. Now, let's look at radicals that have numbers around them. Now, notice I put a table of values here, but I'm betting you can tell me how you would graph this one without a table of values. Think of what you learned in Unit 1. Take that graph that we just did, move everything down 1. Good. So I'll use a different color. So it's root x shifted down 1. I mean, you could use mapping notation, but it's a pretty easy transformation. So we take all the points in y equals root x and we move them all down 1. Okay. Oh, sorry. Domain and range. 0 to infinity. Right. What would you do with the third one? Take the original one and move it everything 2 to the left, right? So it's root x shifted 2 to the right. Sorry, 2 to the left. Thank you for correcting me. Oh. Giving me that. Oh. So I take the original one and I shift all the points 2 to the left. And I get this. Okay. Domain and range. -2 to infinity, yes. And 0 to infinity. No? Wait, yes. 0 to infinity. Good. So you can see how we can shift it around. And that's really just the main focus of this first lesson. It's just to show you what it looks like, the basic one, and to use our previous knowledge to graph transformations of this y equals root x. Now these next ones like I said, you can do it one of two ways. You can do it on the graph if you feel comfortable enough doing it. But if not, if there's too many transformations and it gets a little too complicated, what's the other way? Mapping notation. So for some of you may find this one okay to do right on the graph. You take the original one and you would do what? 3 right, 2 down. So maybe we can do that one. So it's root x, 3 right, 2 down. So remember your basic points though, right? Here's where we start, 0, 0, 1, 1, 4, 2. But from 0, 0 and root x, I go 3 right, 2 down, I start here. From 1, 1, I go 3 right, 2 down, I'm here. From 4, 2, I go 3 down, 3 right, 2 down, I'm here. There's my graph. And I'm going to do 2 graphs on one. Okay. This next one. Maybe sometimes when the stretches and flips are involved, maybe mapping notation. So what are the reference points in the original again? 0, 1, 1, 4, 2, good. And I'll do this one blue. What would be the formula to change every point? X minus 2 because we're taking every x and moving it 2 to the left. 4y because we're taking every y and multiplying it by 4 because it's stretching. Good. So we get -2, 0, -1, 4, and 2, 8. So we get -2, 0, -1, 4, and 2, 8. And you can see that it really stretches vertically. Okay. Next one I want you guys to do, or even the next 2. Okay. And you can do it on your own, do it with a partner, bounce ideas off somebody else. Okay. But see if you can figure out the next 2. If there's something weird about C, you might have to move something first. Why? So let's say 0, 0. This becomes half or 0.5, -1. And this becomes 2, -2. So 0, 0, 1/2, -1, 2, -2. And it's going to look like that. Okay. Remember, always graph it when you do your points. Graph it from left to right. Yeah. Be consistent. Yeah, this one I just wanted to throw some things at you here. Couple things weird about this. First of all, there's a -3 with the y. How do I deal with it? Just move it over. Add 3. Good. Second weird thing. Yeah, I need the x first. So how would you write it using the x first? Negative x plus 2. Looks a little better, but we're not done. Because when there's something in front of the x, I need parentheses, which means I have to factor.
Can you explain that after? Yeah, actually.
So what am I going to factor out? Just a -1. And what's negative x divided -1? Well, that's positive x. 2 divided -1 is -2. Now I finally got it in the right form.
That's hard, you know.
I know, but you guys can do it. You can do it. Okay? Yeah, this thing is.
Can you explain it again?
Yeah.
But it's slow though, like 0.5 every second.
Okay. Well, it's giving me a lot of seconds. All right. Oh, sorry.
Yeah, I go to DSC. Graph.
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 Well, actually, yeah. Yes. Okay. Do we all see why the -3 is in the wrong place? Right? We need y by itself. So I need to move this over to the other side by adding 3 to both sides. So that's the first thing. And notice when I add to both sides, that becomes the vertical shift. This is incorrect because I need the x first. So there's a negative in front of the x. There's nothing in front of the 2, so it's positive. So if I reverse these, I get negative x plus 2. Are we okay there? Okay, it's the next part, I think. When you have a value for b, okay, meaning when there is something in front of the x, and it could be a number, or it could be just a negative sign, okay? That means there's b here. And if there's something there, I need it in parentheses form. So what do I have to do? I have to factor it, GCF it, to get it in parenthesis form. So what do I take out? I take out whatever's in front of the x. So I'm going to divide by negative, which is the same as -1. So negative x divided -1 is positive x. 2 divided -1 is -2. That's the way it looks. Hopefully that's a little better. So what's the formula? Looks like we got a fair amount of stuff going on here. Negative x plus 2 and
1 plus 3.
1 plus 3. So negative 0 plus 2 is 2, 0 plus 3 is 3. Negative 1 plus 2 is 1, 1 plus 3 is 4. And negative 4 plus 2 is -2, and 2 plus 3 is 5.
1.
2, 3. 1, 4. -2, 5. What's that? Oh, no. If it shifts at all, if there's vertical or horizontal shifts, it's not going to start at 0, 0.
Access.
Now, the last thing is to go backwards. If you're given the graph, what's the equation? This is actually more straightforward than I think when we did it with transformations in Unit 1. So remember, we're always comparing it to the original, right? Here's the original. This is y equals root x. I'm trying to figure out what the red one is. Flip, stretch, shift. Did it flip? No, so no negatives.
Extra.
It's stretched now. We got to figure out how much. Hang on, it also shifted, but let's do the stretch first. Here's so you can tell how much it stretches. On the original, we always had 0, 0, and 1, 1, right? How do I get from the first point 0, 0 to the second point 1, 1? I move 1 across, 1 up. But look at these ones here. Here's the first one, here's the second one. I still move 1 across, but I move 2 up. What does that mean? It's stretched by 2 vertically, by a factor of 2. What letter is that? A. Root x starts here, but this one's starting here. So what letter is that? And now plug it into the radical transformation equation. Y equals A, which is 2, square root, there's no value of B. There's no value for H, so it's just X underneath. And at the end, it's, try the last one. Did we get it? Y equals root x plus 2 plus 3. It only shifted. No flips, no stretches, because if you look at the shape of the two, it's the same. Okay? And this last one's going to make you think a little bit. What would be an equation of a radical function if the domain was x is greater than or equal to -3 and the range was y was greater than or equal to 4? Say it again. You guys. So go over 3. Why don't we, like, do you think a graph might help? If I could see it on a graph? So think of it this way. If x is greater than or equal to -3, doesn't that mean the furthest left point has to be -3? Yeah. So it's got to be here somewhere. So I know it's going to start here and then curve that way. But it also has to be, the range also has to be greater than or equal to 4. So doesn't that mean that the lowest y value has to be 4? So the lowest x value is -3. The lowest y value is 4. It must start here. And since if we're not told there's any flips or stretches, it just goes like this.
Sounds.
What's that equation? It just shifted twice. It had two shifts in it. Root x plus 3 because it moved to the left 3 to get that domain. And then plus 4 because it had to move up. So when you see a question like this, these will help you get the starting point of the radical. So if it's -3 for domain, go over -3. And then if it's greater than or equal to 4, go up 4, and that's where you start. You could, like I just said, to me, it's going to start at -3, 4. So that means it's shifted to the left 3 and up 4. So it certainly is possible to do it without a graph. Yeah. Because we weren't given that information at all. We would have to be given it. Like we would have to be told it flipped. Or we would have to be given a little bit of different information on the domain and range. Like here, this is, if I said this, what would that one look like?
I don't know.
It's still, okay, it's still the same starting point, but this is less than -3. So which way is it going to go? Which means there's going to be a flip. Okay? So that's how we would have to address that one. That's a good question. Very good question. Okay.